So they ask you to find an interval endpoint, which is really just an x-intercept. But notice this is not, there's no y in this inequality, is there? Okay? So there's no, right, they essentially did, but you can't just assume that. So you can't assume that this would be graphed two-dimensionally where you would need x-intercepts, okay? So they just do this problem one-dimensionally, and they call them interval endpoints as if you only had an x-axis, and in other words, where would these points be on the x-axis, okay? So if I were to take that problem and look at it from its corresponding functions perspective, it would look like this. X squared, x plus 7, whoops, let me put the f of x's in front of that. You would look at it like this. F of x is equal to x squared times x plus 7 times x minus 6. Okay? So asking you to find interval endpoints for this is the same as asking you to find the x-intercepts of this. Does that make sense? So to answer this question, we are going to look at this function. Okay? So we practiced graphing these the last time we talked about 5.1. If I were going to graph that, then I would, first of all, I want to find my leading term. What would my leading term be? It would be x to the 4th, right? Because I have x squared times x times x. So if my leading term is x to the 4th, what does that tell me about how this graph will enter and leave? Happy face parabola, right? And where does this thing cross the x-axis at? 0, -7, and 6, right? Bounces at 0, crosses at -7, and crosses at 6. So this graph is going to come in here, cross at -7, turn around somewhere and bounce off of 0, then turn around somewhere and go through the 6. Okay? So it comes down, it goes through -7, back and bounce around here, and exit this way. All right? Your interval endpoints are these three things right here. Okay? -7, 0, and 6. So when it asks you to find interval endpoints, these are not going to be entered like an ordered pair because you don't even have a y in the original problem. So you're just going to say a box will pop open and you'll put 0, -7, and 6 as your interval endpoints. And that is your answer for step 1. Is everybody okay with step 1?
Yeah.
Yep.
Okay. All right. Step 2 is going to be to solve this inequality. So let's see your instructions for step 2. Let me shrink this down. Step 2, they're going to say test each interval to see which satisfies the inequality. Step 2, test each interval. I would write out these instructions so that when you see them, I copied them pretty much directly from the problem, so it'll make sense to you. Test each interval to see which satisfies the inequality. Okay, well, in order to know that, you have to understand what this means from a function perspective. If this says greater than 0, that means where is this function above the x-axis? Okay, so let's write out some descriptions of that. If you have a function and it's greater than 0, that means above. Where is it above the x-axis?
Before and after it causes.
Okay, so let's list out the other possibilities as well. If they say f of x is less than 0, that means where is it below, correct? Below the x-axis. What if they say f of x is greater than or equal to 0? What does that mean?
Where it touches.
Okay, where is it on or above, right? So it means on or above the x-axis. okay? And then, of course, if it says less than or equal to 0, that means on or below the x-axis. Does that make sense? Okay? So what case do I have here? I have a greater than 0. So that means what? Above the x-axis. So when I look at this picture, where is this picture above the x-axis?
From negative infinity to -7.
Okay?
6 to positive.
So I'm going to use a different color to code this. So let's say I use green. From here to here, you're above the x-axis, right? And from here to here. And I do not want to be on, so I'll put an open circle in green there to show I'm not including the x-axis. But so if you divide this up into intervals, we have from negative infinity to -7 being green. I'm looking at this in terms of the x-axis. Where is this graph above the x-axis? From negative infinity to -7, unioned with 6 to infinity. Does that make sense? Okay, so let's say we said negative infinity to -7, but don't include the -7, right? Unioned with 6 to positive infinity. Like that. Yes, Doug?
Would there be a scenario where you would include like the -7 or the
Yep.
6?
Sure. Everybody okay with that? Okay, so I'm going to take that exact same problem, and instead of doing a greater than 0, I am going to do less than or equal to 0. Okay? So exact same problem. So we're going to make this example 2. Example 2. Okay, so same function, but this time instead of being greater than 0, I'm going to do less than or equal to 0. So exact same function, just less than or equal to 0. So I want the exact same picture as I had over here, but this time I want to worry about where it's what? Below the x-axis, or remember my symbol is less than or equal to. What does less than or equal to mean? On or below the axis. So where is it on or below? Well, that would be from here all the way to here. Do you agree? On or below would be all the way from -7 to 6. Do I include them or not? You include them because it says below or on, right? So on means to include. So for this problem, my answer would be -7 all the way to 6, including both. Does that make sense? Where is it below or on the x-axis? Okay, now this time I'm going to do example 3, and I'm going to use the same thing again. Only this time, instead of less than or equal to, I'm just going to use less than. Okay, a little smaller than I wanted it to be there. Changing this to just a less than. So in your notes, you're going to write example 3, same function, but less than 0. So this time, I mean below the x-axis, but not on the x-axis. Right? Below, but not on. Just below, and that's it. Okay? So where is this graph? Below, but not on the axis. Below, but not on.
Including 0.
-7 to 0, not including 7, 0.
So for here to here, but I better stop right there, and from here to here. Do you agree? So in other words, I've got open circles on all these. Okay, so if I'm saying strictly below but not on, I've got to go from -7 to 0, and then union that with 0 to 6, not including those numbers. Okay, so I started at -7 but don't include it, and I go to 0, don't include it, Union that with 0 to 6, don't include the number. Because I only want to know where it's below the x-axis, not on the x-axis. Does that make sense? Okay? And so that's essentially what this lesson is all about, is making that look like a function and then figuring out the graph, where is it above, below, on, and so on.